Hey everyone, I had a request on my rosette making video to go back and explain my compass cutters a little bit more, so I thought, yeah, I can do that. Although it makes me a little bit embarrassed because I'm the sort of person who builds a jig in the spur of the moment using whatever materials at hand, and unless there's a problem with it, I don't actually go back and refine the design. So these look a little bit rough, but they've been serving me well for a good many years now. They both operate on the same design, two beams that slide back and forth against each other. The lower beam here has a 1/4 inch diameter steel rod that I've glued in place, and there's also a recess for a flat-headed furniture installation bolt. It's a 1/4 20 that goes up through the top beam and is secured with a washer and a knob. There's a little channel in there for it to go back and forth. On this side here, this is an important design feature. The width of the beam at this point is the same as it is here, so that when it's in operation, this surface will be in contact with the soundboard, and that gives you good support. Let's go back and have a look at another compass cutter and tell you why that's a primary consideration. If you walk into any art supply store, you'll probably see one of these. This is an Olfa brand mat cutting compass, and at first glance they seem to be the answer to all of your problems, but in practice they're very difficult to use on wood, because when you start penetrating the surface of the soundboard, the tendency is to go deeper with the spike than the cutting edge. You'll go in there and it'll actually start tilting on you, and that will give you either an irregular hole or a sidewall that isn't perpendicular to the soundboard. You can rock backwards and forwards. The other thing is there isn't an effective depth stop on these, and if you're not careful you'll actually make a hole all the way through your board. With this design I can just set the depth I want here. In this case it's 1.5 millimeters. I'll spin it around until it bottoms out on this surface, and I'll know I've reached the correct depth. There are some things to consider about the blade that you use in this. You could use an X-Acto knife or a surgical blade, but you'll find that they're quite thin and they tend to wobble around in the cut if you're not careful. I've been using these. These are exchangeable blades from a Warren wood carving set. You can buy them online individually in a number of different profiles. What's nice about them is that they're quite robust and they're very sharp and not too expensive. To hold them in place, as you can see, I've gone extremely low tech, just a couple of countersunk screws and a block of wood that squashes it against the main body of the jig. Another point about these blades is that they have a bevel on both sides. A lot of compass cutters come with a single bevel blade, the idea being that as it's going through paper, it'll create a nice perpendicular, straight-sided cut. When you're dealing with wood, though, these things will cleave the fibers and they'll actually compress them on both sides. And you won't have an issue where you've got all of the pressure bearing on one side of the blade or the other. If you hit a winter grain line or something that's hard in your cut, it'll tend to deflect off, and then you'll find that once you get off track with this kind of thing, it's virtually impossible to make a correction and get it back into the right path. So a double beveled blade is better for this procedure than a single beveled one. The router compass works in exactly the same way. Same 1/4 inch pin, same two beam arrangement, locks in place, and the same support on the other side of the router bit in this case. They both work in conjunction with a piece of plywood that's flat, and it has a bushing, I think it's bronze, a 1/4 inch bushing in there that mates with that pin. What that does is give you a good solid surface to contact with. If you're going through a softwood soundboard that's maybe 3 millimeters thick, that's not a lot of area to bear against this pin, and if you're not careful you can actually compress it and make it slightly oval or out of round, and you'll end up with an eccentric hole if you're not careful. So this gives us good solid contact. I'll demonstrate the procedure. I've got a ukulele soundboard here, which I've taken to close to the right thickness. I haven't refined the surface yet, but I marked my center line and the center of my sound hole here with an awl. And the first order of business is to use a brad point bit, 1/4 inch, to drill a hole there for my pin. I'm just double checking to make sure that my depth is about 1.5 millimeters. And as for the distance from the cutter to the pin, this is a 6 millimeter diameter pin, so half of that being 3 millimeters. I'll subtract that from whichever radius I want to cut into the soundboard. I want 35.5 millimeters. This is it. So 35.5 minus 3 would be 32.5, and that seems about right. Just making a very, very delicate score line here to see how it lines up with the pencil line that I had previously drawn, and it's bang on. Nice. So the first time we do this, we want to go along very, very, very lightly. Just the barest, tiniest little penetration, and that'll give us a guideline. It's easier to do that lightly so that we don't end up being affected by grain or changes in the grain direction. And once we've established that initial scoring line, we can be a little bit more forceful, and the cutter will follow it right down to the proper depth. Like so. Now we'll just reset the cutter and I'll do the outside of my ring. To excavate the channel between the score lines, I like these Onsrud brand spiral cut bits. They give a nice clean shearing action. They're the high-speed steel version as opposed to the solid carbide because as they come from the factory they're a little bit too long for my Makita laminate trimmer setup here. So I go in with a Dremel tool and abrasive cutoff wheel and cut them back a little bit. Wouldn't be able to do that if they were the solid carbide version. To set the depth of cut for the router, I have a little thing that I've glued up from various pieces of veneer here, and I can use that to sight either 2 millimeters or 1.5 millimeters or 0.5 millimeter, depending on what I'm doing. Just a quick little expediency. To line up the cut on the inside here, you can see at some point I had to plow away a little bit of the plywood sub-base so that I could get a clear line of sight right down to the end of the bit and make sure it's tracking in between the scored lines. I'll start routing up at the top end in the area that will eventually be covered by the fingerboard. Because I've got the score lines there, I don't have to worry about which direction I go. I can just go in a continuous circle. If I didn't have them, I would have to start at 12 o'clock and 6 o'clock and alternately work in quadrants around so that the fibers would always be supported and that they wouldn't break out. Because I've got the lines, I don't have to worry about that. Now the little bit of chaff that's left in the corners there I can get at with a little carving knife or a little chisel, as I've shown before, and I'll clean that out. Nice flat bottom channel, all set to go. Thanks very much for watching. We'll see you again soon.